This is Josh White from JW Math Tutoring. In today's video, I'm going to cover 10 problems from the June 2025 Digital SAT Math Test. So let's go ahead and take a look.
But life is a dream that calculus could never predict.
Welcome back to June 2025 SAT problem set number 3. Just before I start working through these problems, I want to mention a couple things that I mentioned at the start of all these videos. First, obviously, if you like this video, please do give it a thumbs up, subscribe to my channel, and sign up for notifications. Second, if you haven't done so already, check out the videos for worksheets number 1 and 2, which are already posted, and also for worksheet number 4, which will be posted shortly. In addition to that, these are all problems that I have gathered from various sources, mostly Reddit, a couple from Discord as well. So you may recognize these problems from the test if you took it in June. And I've tried to make them as realistic as possible. However, there might be slight differences between, say, the numbers you saw in the test or the setup of the problem that you received if you took the June test. So just keep that in mind. I've tried to, do as best I can to essentially recreate the problems based on what people have reported. That means that some questions are going to be done as free response when on the test they might actually have been multiple choice. So just keep in mind there could be additional solution methods if a problem is multiple choice as compared to being done as a free response question. Besides that, there'll be a link to the worksheet for these problems in the description of the video and also in the pinned comment. And otherwise, let's go ahead and get started. So problem number 1, here we have a circle and you're told about the measure of an angle in the circle given in degrees. So let's say here's our circle. All right, so now here's our center O. Here's point A. Okay, here's point B. So we have this angle here, in here, 20 degrees. And the length of this arc is 8 pi centimeters. So right here, this small arc is 8 pi. Okay. What is the radius length of the circle? So there are two methods you can use to solve this. The first method is, if you're familiar with the equation S equals r theta, S is arc length, r is the radius, theta is the angle, but the measure has to be in radians, not degrees. So if we're going to take this approach, we have to take the 20 degrees and we have to convert it to radians by multiplying by pi over 180. You could also do 2 pi over 360 if you wanted to. But what that will do is that will convert this angle to pi over 9 radians. Now that we have that, we can just plug in the angle measure and the arc length to solve for the radius. So if you notice, if we rearrange this, the radius is just going to equal s divided by theta. So it's just going to be 8 pi divided by pi over 9. Now, if you're not familiar, or not familiar with, but if you're not comfortable with dividing, these fractions and everything, you can just go straight to Desmos and, just type this into Desmos. The pi's are going to cancel, and then it's really 8 divided by 1/9. The 9 ends up coming up top, and the answer ends up being 72. So the radius of this circle is 72 centimeters. Now, here's an alternate approach you could take if you are either not familiar with that equation or you don't want to bother converting the angle measure to radians. Basically, what you could do is just set up a proportion. And we could say, okay, 8 pi is the arc length that corresponds to a 20-degree angle. Okay, so what's going to be the arc length that corresponds to the entire circle, or in other words, 360 degrees? So you could go ahead and solve this, just cross multiply. You should get 20x equals 2880. X is going to equal 144 pi. Let's just go to Desmos to confirm that. Eight pi divided by 20. X x1 over, I'll just use regression. Okay, so notice here it's going to give us a decimal value. It's not going to have the pi in it, but that's fine because if I just take this and I divide it by pi, slide this up, notice it's 144. That just confirms this is equal to 144 pi. Okay, anyways, so we have the right value for this x. So x is really the circumference of the circle. In other words, all the way around the circle corresponds to the 360-degree angle. So this you can set equal just to 2 pi r. So now to get the radius, you're just going to divide this figure by 2 pi. So the radius is again going to equal 72, but if we go to Desmos, we can just confirm this. So I'm going to take my x1, the value I got from this regression, and just divide it by 2 pi. And notice I get a nice integer answer of 72. And this is just an alternate approach you could take, again, if you don't want to convert the angle to radians, don't want to take the approach using the equation relating arc length and angle measure and radius. All right, next question. This is a repeat question. This is not only appeared on previous official exams, but it also appears at the end of one of the newer, Blue Book practice tests. So first I'll show you kind of like the theory behind this, and then I'll just show you obviously how you could just do it in Desmos, just using the calculator. So the whole idea is that like the sine of an angle is equal to the cosine of 90 minus that angle, or vice versa. The sine of 90 minus an angle is equal to the cosine of an angle. So essentially, what we're going to do here, we're going to notice is 25 and 65 are complementary angles, i.e. they add up to 90 degrees. Or in other words, 90 minus 25 is 65. 90 minus, 65 is 25. So if you take this, like, say, first equation here, right? You say, okay, if x is 25, then the sine of 25 is equal to the cosine of 90 minus 25. Well, 90 minus 25 is just 65. So the point is, you can replace sine of 25 with cosine 65. And then if you go through the same process for the second expression, basically put in 65 here, and then 90 minus 65 becomes 25. This gets replaced with cosine 25. So you end up with basically the cosine of 65 degrees squared plus the cosine of 25 degrees squared. The correct answer for this problem is letter B. Now, that is basically the theory behind it, but maybe you're not familiar with that, maybe you haven't learned that, and that's fine. You technically don't need to know that in order to solve this problem. You can solve this problem in Desmos by just matching expressions. And so here is what I mean. Let me just erase all this so we see everything clearly. Okay. So all I'm going to do is I'm going to type the original given problem, and then I'm going to type the answer choices, and only one of them should match it. Now, we do want to make sure, slide up here, that we are in degrees, not radians. So we click the little wrench icon, we change it to degrees. All right, what's going on here? Oh, I need to, sorry, you have to multiply. I have to put the multiplication symbol in between these, otherwise it's going to mess up. What's going on? Use parentheses around the argument of sine. Okay. All right, there we go. Get all the parentheses entered, and we get an answer. Turns out this is equal to 1. All right, so now you can just go through, and we can type in each of the answer choices. So answer choice A, is it equal to 1? No, it's wrong. Move on. Let's see, answer choice B is the same, but we need to change this sign to cosine. Is this equal to 1? Yes. This is the correct answer. Technically, you don't need to go any further, but I will just show you. Answer choice C here, you get a number which is not 1 or other than 1, so that's wrong. And now answer choice D, let's put a plus here, let's put a 2 in front, and this needs to be 65, 2 sine 25 plus 2 cosine 65. Again, this is not 1. This is something different. So that just confirms the correct answer is B. That's how you could do this entire problem in Desmos, just by matching the value of the given expression to each of the answer choices. Okay, question number 3. This is a repeat question. This one is an old one. First appeared back in, I can't remember, March or May of last year, 2024. The basic approach, the basic shortcut is, for this problem, when you have something like this, which it's not a quadratic, because it's not, z squared and z, but it's similar to a quadratic. It's like z to the 18th and z to the 9th. The basic approach is the answer is just going to be a times c plus 1. This is our a, obviously this is our b, this is our c, and that's it. That's the shortcut. That's how you get the answer. Now, the way it actually works out, if you go to factor it, basically you're going to have z to the 9th, you're going to have z to the 9th. What you're going to do is, your two factors that you put in here are going to be for the a, it's going to be 30 and 1. You're going to put 30 here and just, whatever, 1 there, which you don't need to write. And then for c, it's going to be the same. It's going to be 38 and 1. But you want the 38 to be paired up such that it will multiply by the 30 here. And then this is just going to be a plus 1. And we'll put a plus there. And so now if you go ahead and FOIL this out, 30 z to the 18th first. Outer, 38 times 30 should be 1140 z to the 9th. Inner, 1 z to the 9th. Last, 38 times 1. Okay, so this part checks, these matches those terms, and then here we have 1140 plus 1, or 1141, which is the correct answer. Let me just confirm in Desmos. 38 times 30 is 1140, right? And then we just add the 1, so 1141. So just memorize, this is the shortcut. This is what the answer is going to be if you come across a problem like this. All right, next up, this is another old question that's appeared on a number of previous official exams, and there is a shortcut you can use to solve this. I will show it at the end. First, I'll show the theoretical way to solve it. Then I will show how to do it in Desmos. Then I'll give you the shortcut at the very end. Okay, so if you're going to solve this by hand, what you would do is you would square both sides. On the left side, you get k minus x. On the right side, just to save some time, it's going to be 3136 minus 112x plus x squared. Basically, you write 56 minus x twice, and then you FOIL it out. Okay, now we get everything equal to 0. You get x squared minus 111x, another one there, plus 3136, and then we got to move the k over, minus k. Again, I just added x here, and I subtracted k. Move those over. Now you can basically set up the discriminant, b squared minus 4ac. And when you want exactly one real solution, you would set that equal to 0. So we're going to have negative 111 squared minus 4 times 1 times 3136 minus k, and we set that equal to 0. I'm not going to bother solving this by hand because I can just go to Desmos and I can just type in a regression statement to get the answer. Minus k tilde 0. Okay, so that's the value of k, but notice the question doesn't want k. Just scroll back up here. The question wants the value of 4k. So what is 4k equal to? 4k is equal to 223. Okay, so the correct answer to this problem, what you would type in is 223. Now, let's see how you could solve this on Desmos. So all we're going to do is, the general approach is basically we're still going to square both sides to turn it into a quadratic, and then we're going to basically get it equal to 0. So, okay, the root k minus x squared just becomes k minus x. And then for the other thing, for the other expression, the 56 minus x quantity squared, I'm not going to actually square it out. I'm just going to leave it, like that. You don't have to bother squaring it out is the point. Then I'm going to do regression, and I am going to send this into its vertex form, because this is a quadratic now, but the y-coordinate is going to be 0. So instead of having a plus k at the end here, I'm just going to put nothing, because I want 0. I want it to basically be 0, because that would mean that the vertex is on the x-axis, which means there's only one real solution. If you want more info about how this works, check out part 10 of my Ultimate Desmos Guide to Digital SAT Math. I go through this specific type of operation in detail and work through several problems showing you how to do it. Okay, so now we just need to define our list for x1. Okay, so once I've typed numbers in there, a couple of numbers in there, notice it gives me the k value that I had previously. And again, I don't want k, I want 4k. So what is 4k? Now the thing that's unusual is sometimes with these regressions, like notice here, something's wrong where it's not coming out to 223, which is the value you want. So on all of these problems, the value, like this minimum value of 4k or whatever, it's going to be an integer. Because when you solve it using the technique I showed initially, using the discriminant, it comes out to an integer. You're not going to have a decimal like this. I don't know why it's doing it here. There. It looks like if I add another value, then it's able to, like, I don't know, get rid of the decimal things. And see here, it even keeps it even when I delete them. So I don't know. If you have an issue where it's coming out with a decimal like that, just add another value or two to the list and see if that will fix it. But in any case, the answer is 223. This is how you could do it entirely in Desmos. Now, here's a third approach. Again, here is a shortcut just like the last problem. The 4k value for this specific setup, this type of problem, will always work out to be 4n minus 1. And when I talk about n here, I'm talking about this number that is either like the number minus x or x minus a number. Whatever the number you see in the problem is, the 4k value is always 4 times that minus 1. It always works out like that. 223. There it is. So you can just memorize that. I went through in one of my videos, basically an alternate solution video, I went through and worked out algebraically to show why that happens, like basically solving the discriminant, but with, with n in it instead of an actual number for it. But that's the shortcut approach. It's always going to work out like that. Okay, let's look at this next problem, number 5. This is a percentage problem. So basically, what's happening here is you have this amount of money earned in 2016, okay? Then in 2017, it went up by 11%. Then in 2018, it went up by another 3%. The way this is worded, I think, is a little confusing or difficult for some people. Basically, what it's saying here, this earned in 2016, y times so much, basically what it's saying is, you take the 2016 earnings down here, you multiply this by, the amount you earned here is equal to the 2018 earnings multiplied by y. You're multiplying the y by the 2018 earnings, not by the 2016. You're multiplying it by the 2018 earnings to get the 2016 earnings. That's how it's supposed to be set up. That's, I think, what they're asking for in the problem. So essentially, really what it's, what you're doing here is you're taking 2016, you increase that by 11%. That's the same as multiplying by 1.11. It's really 1 plus 0.11, which I just made to 1.11. Then you take, this whole amount, which is the 2017 amount, and you increase it by 3%. That's the same as multiplying by 1.03. Once you do that, you get the 2018 earnings, okay? So now you go ahead and to solve this for 2016, you're just going to divide both sides by 1.11 times 1.03. So in other words, 2016 is equal to 1 over 1.11 times 1.03. And this entire thing, this is the y value. This is the number they're asking for in the problem. So basically, it's going to be letter C. It's right here, 0.87466, blah, blah, blah. Correct answer is letter C. I mean, you could take numbers here, and you could actually, like, if you wanted to, you could work it out with numbers. So just to go to Desmos and show you. Starts off at 100. Okay, after 2017, it's that. Then after 2018, it becomes this. So now you're basically saying, okay, 2016, I'll call that, my x1, is what value, actually here, sorry, 2016 was 100, that's what I started at, is y times my 2018 number. Actually, I don't want to use y, because let me just pick whatever random letter, b. So 2016, which I started with $100, let's say, is b times, and then this whole expression represents the 2018 earnings. And you can see here for b, I get the 0.8747 if it's rounded, or 0.4661. Same number I got by doing it using this method. So if you want to use actual numbers to think about it that way, that's fine too. It's basically the strategy of picking numbers, but the correct answer for this one should be C. All right, let me just erase some of this stuff, and then we can look at question number 6 here at the bottom of the page. So here you have an equation to solve. Basically, what interval is x plus 3 located in? So if you want to go ahead and solve this, I mean, basically what you want to do is say cross multiply it. 7x plus 21 equals 5x plus 15 here, here. And you get 2x equals negative 6 divided by 2, x equals negative 3. Now, you have to be careful. They want to know the interval that x plus 3 is located in, not x, not negative 3, but x plus 3, which is negative 3 plus 3, which is 0. So which of these intervals is 0 located in? Well, between negative 4 and negative 2? Nope. Between negative 3 and 0? No, because it's not equal to it. It says strictly less than it. Between negative 1 and 1? Yes. Between 2 and 4? No. So the correct answer is C. Now, the other thing you might be able to notice or figure out is if you look at this equation, so because the numerators are identical, but you have different denominators, like the only way for these two fractions to be equal is if the top has to equal 0. Like the only way you can have something over 5 equal something over 7 is if they're both 0 over 5 and 0 over 7. Because then they're both equal to 0. Any other value, you'd get two different fractions and the equation would not be true. So that's like a shortcut you can use if you recognize that, but you don't need to. You can still, you see solve this out. It doesn't take that long. Moving to the top of the next page now with problem number 7. This is a repeat question that has appeared previously. Basically, we have a cube, but there's no lid on it. And we know every side is 47 centimeters in length. We want to know the total surface area of this box. Again, remember there's no lid. So obviously the area for one side is just going to be s squared, or 47 squared. And that's just going to be 2209. And then we just have to multiply that by 5, since since this box only has 5 sides, 5 faces, because again that there's no top, there's no lid. So we just take this times 5. Correct answer would be 11,045 square centimeters. Of course, we don't need to enter in the unit, so 11,045 is what you would fill in or grid in, and we can move on to the next question. All right, let's look at number 8 now. This one is a repeat question that has appeared previously, I think in 2024. So with this question, it's asking you for two constants. One is equal to the y-intercept value. The other is equal to the product of the roots. It turns out that on this problem, they're both going to be the same number. So in other words, q plus r is technically going to be 2 times some value. The reason it works out like that is the following. Let's start with q, y coordinate of the y-intercept. All right, so if these are the x-intercepts of this graph, of this polynomial, that means we could technically write it in its factored form as, x minus c, where c is like each of these values. So in other words, one factor is going to be x minus negative 6, or I'm just going to change it into x plus 6. Because remember, once you have a polynomial and it's factored, you take each factor, you set it equal to 0. So if you take x plus 6, you set it equal to 0, you solve that for x, you subtract 6 on both sides, and that's how you get x equals negative 6 for your intercept, for your root, for your solution, for your 0, whatever term you want to use. So that means we're going to have another factor of x plus 4 from the negative 4, and then x minus 2 and x minus 3. So this is what the factored form of this polynomial would look like. I mean, again, there might be a number in front here. So now, constant q is equal to the y-coordinate of the y-intercept. So to get the y-intercept, that just means we let, x equal 0. So you plug in 0 for all of these, basically for all these x's, in every parenthesis. Notice you're just going to get 6 times 4 times negative 2 times negative 3. Basically, it's just the opposite of each, these x-intercept values that you see here. So we go ahead, we multiply this all out, and we're going to get 144. We can just go to Desmos to confirm. All right, so we get positive 144 for q. Now for r, basically these x-intercept values are the roots. So notice now for r, it's like we're going to be technically multiplying negative 6 and negative 4, but positive 2 and positive 3. So it's the same numbers, and it's also like the same number of negative signs. So the answer is still going to be positive, and it's going to be, again, 144. It's 6 times 4 times 2 times 3, and there's 2 negatives, which means the overall result, the overall answer is positive. So q plus r is just 144 plus 144, which is 288. That's the correct answer. That's what you would fill in for this problem. All right, next, let's look at number 9, the bottom of the page. There have been lots of problems similar to this previously. Maybe not that this exact, wording or these exact numbers, but the whole idea of you have a data set, you do something to the data set to change it. Maybe it's adding a value, maybe it's increasing every value by a certain number, or whatever, something like that. And then they ask, okay, what has changed or what is different between the first data set and the second one? So in this one, you have your first data set. It's 55 integers between 35 and 85. So we don't know what the exact numbers are, blah, blah, blah. But okay, something here, 35, to 85. And then in B, basically it's the same 55 numbers, but you also add just one single value of 10. Okay, so the way this is intended to be wording is we're not adding 10 to every number. We're only adding a single value of 10. So the first one had 55 values, the second one has 56. Okay. Which of the following must be smaller for B compared to A? So if you look at the mean, data set A is going to have some mean somewhere here between 35 and 85. We don't know exactly what it's going to be, but we know it's going to be between those two numbers. Then for B, basically when you take 10 and you add that, that's going to pull the mean down. It's going to cause the average to decrease because you're adding a value which is lower than the existing mean. So for the mean, for dataset B, it is going to be lower than or less than the mean for dataset A. So 1 for sure is true. So we can get rid of this, and we can get rid of this. The question is now, what about the median value? So we don't know exactly how the values are distributed, both in A and B. Therefore, we can't tell what will happen with the median value. It could stay the same, or it could go down. So basically, in A, there's 55 integers, right? So that means when you go to look for the median, basically it's like you have the 27 lowest integers, and then you have the one median value in the middle, and then you have like the 27 highest integers. So this is, and this would be your median. Now for B, when you have 56 integers, technically it's going to be like, you could say you have 27 on the left, 27 on the right, and then you have your two values in here in the middle, and you average those, and that's your median value. But the problem is you don't know what these specific values are. Like it could be that the median goes down by adding this 10 in at the bottom, or it could be, like I said, it stays the same. If the middle three values in the original data set are all, let's say, the same number, say it's like, whatever, 40, 40, and 40, and then you add this 10 in, okay? So now we're going to start, like you have this 10 here. So now the 27th value in this is really, I guess we would actually need this to be 40. The top one on the one end, it wouldn't matter. We would need like say the 27th and 26th values here, sorry, to be 40, just to demonstrate this. So now the 26th value is now the 27th. That's 40. And now the 27th is now the 28th. And now the 28th is now 29th. Anyways, the point is, it could work out such that the median is 40 in the original, and yet the two numbers you average to get the median in the new data set is 40 as well, because the 28th and 29th values would each be 40, and you average them and get the same thing. But it could also work out that the numbers are different and that the median goes down based on how the distribution is. So the whole point is we don't know what happens to the median. The correct answer is A. It is only the mean, which must be smaller for dataset B compared to dataset A. All right, let's look at this last problem now. Number 10, top of the last page. This is a repeat question. Has appeared. Can't remember if it's on the blue. I believe it's on the Blue Book practice test, but I can't remember which one exactly. So there are two different ways you can solve this, basically using the idea, the concept of similar triangles. So we have two different triangles here. A, B, C, okay, D, E, F. I should say two different right triangles. All right, we know tan A is equal to root 3. So tangent of A is opposite BC over adjacent AB. So that's root 3. But we could also just write it as root 3 over 1. Root 3, you can make this 1. And we know DE is 121. Find the length of DF, the hypotenuse of the triangle on the right. So there's two ways you could look at this. I'll show both methods. First method, I would say, is to note that AC is going to be 2. And you can either get that by noting that, recognizing these ratios, that it's a 30, 60, 90 triangle. Or you could do Pythagorean theorem. 1 plus 3 equals AC squared, 4 equals AC squared, AC equals the square root of that, which is 2. Or, I mean, technically you could also do basic trig, and you could find the measure of angle A, and then you could use the measure of angle A and one of the sides to find AC as well, if you, for whatever reason, you didn't want to do Pythagorean theorem. Okay, so now that we have that, now you can just set up a nice ratio, or proportion really, between the two triangles to find DF. So we can just say, all right, AB corresponds to DE. AB is 1, or at least we're setting it equal to 1 in our example. DE is 121. All right, and then AC is going to be 2, DF, we don't know. So at this point, notice it's just times 2 to get to the right. Multiplied everything by 2 in order for these to be equal, but you could also just cross multiply and you get DF equals 242. Basically, in general, the scale factor, at least for the numbers I'm picking here, from triangle ABC to triangle DEF is times 121. Multiplying every value by 121. So correct answer for this for DF is going to be 242. An alternate way you could do this, I think this first way is kind of the way most people do it. It's a little more straightforward, but an alternate way you could do this is you could also note that you would not have to figure this out, by the way. And technically, you wouldn't have to find AC to use this method. You could set up a ratio to find EF. You could say 1 over 121 equals root 3 over EF. And that means EF is just 121 root 3. And then you could just use Pythagorean theorem to find DF. So obviously for that, I would go into Desmos, and I'll just type it in, root 3, using regression, since it's so much faster, quicker, easier than to solve it by hand. So 121 squared plus 121 square root 3 squared. I'll just use d squared. All right, d is 242, and that's our answer. So this is an alternate approach you could take as well, where you just set up the ratio first to find EF, and then use Pythagorean theorem to find the third side in that triangle. But either way, correct answer is going to be 242. All right, so I hope you enjoyed this video going through 10 more problems from the June 2025 Digital SAT Math Exam. If you did, please do give this video a thumbs up, subscribe to my channel, and sign up for notifications. Also, if you haven't done so already, check out the videos to parts 1, basically worksheet 1 and worksheet 2. And once it is posted, worksheet number 4 as well. If you have any questions or comments or alternate solution methods, please do leave them in the comments below. And lastly, if you're trying to improve your Desmos skills to help master the Digital SAT Math section, please check out my Ultimate Desmos Guide to Digital SAT Math. It's up to 10 total parts now, has many advanced use cases of regression, showing you how to solve some of the hardest digital SAT math problems that you'll find at the end of Module 2. And it has almost up to 60 total practice problems now as well.